So our today's topic is advanced computer network, in that routing. Okay, distance vector routing we are going to learn today. So let's see how distance vector routing is happen, and after that I will show you one demo in which you can able to see the how packets are travel in distance vector routing. Suppose in a network you have one source and one destination. In that you send one packet from the source, and you have one more network in between source and destination. So at the time of routing, when packet comes to the router, it check the destination is the shortest distance, and routing information is available in the your routing table of router. So according to that, the packet will route to the exact destination router, or it is forwarded to that desired destination router network. Okay, rather than it is forwarding towards the unnecessary other network which is in between the source and destination. So by checking the next hop, it check whether destination is available with that hop or not, and after that checking it will be moved forward, and also it check the shortest distance at the time of routing. Okay, so I have one video which shows the how routing is happen. Okay, let's check.
To destination host when we transmit a packet. A network system includes several routers, and distance while transmitting a packet from source is the packet requires number of hops, say number of routers to reach its destination. So finding minimum distance is based on the calculation of the metric, say cost, or here we can see the distance from source node to the destination node. Here nodes A, B and C are representing routers connecting networks, and numbers in between are the distance between the routers. So the distance between node A to node B is 2, and distance between node B to node C is 5. The core of distance vector routing is actually Bellman-Ford equation. How do we find minimum distance based on Bellman-Ford equation? As shown the graph, it contains source node X and destination node Y in between three intermediate nodes A, B and C. Here the first graph showing a node X is sharing its vectors, that is distance, to intermediate nodes, to its neighbors actually, that is A, B and C. So C suffix XA here is representing the cost between node X and node A. And the second graph is showing a vector updating a path with intermediate nodes, that is to find a minimum distance to the destination node Y. For example, an internet is shown here, and these symbols representing routers, and in between a box shown representing networks. Several networks are connected with routers, and the weighted graph shown here having nodes A to G, and the cost, or say the distance between all nodes, are shown as numerical values. The least cost tree technique from a node to all other nodes in an internet is helping to find the least cost path from source to destination. This least cost tree method has been discussed in our previous lecture of unicast routing protocol introduction. That is, here n nodes in an internetwork having n into n minus 1 least cost paths. That is, each node in an internetwork has n minus 1 least cost paths. Here in this tree diagram, least cost paths from node A to all other nodes are 6. That is, n number of nodes are 7 and it has n minus 1 least cost paths. That is 6 paths. Let us take the same example of internet system. Here, the 7 nodes are showing the 7 routers, and in between the numbers showing the distance between those routers. The first step is to the calculation of distance vector of all individual nodes. So initially, all nodes are calculating its distance vector to other nodes. The distance between node A to node A, it remains the same place. The distance is 0. The distance between node A to node B is 2, and the distance between node A to node C, there is no direct path. There is an intermediate node. So the vector here is actually infinity. That is, initially the node can have its distance with its neighbors only. And the destination node with the intermediate nodes will be marked infinity. So next, the distance vector from node A to node D, it is 3. That is its neighbor. And there is intermediate nodes between A to other nodes E, F, G. So the first distance vector of node A to E, F, G are infinity. So by the same way, the distance vector calculation initially for all nodes are calculated as the least cost path from the node to other nodes. The distance vector of node B is having all its neighbors' distance value. The neighbors of node B are node A, node E and node C. Other nodes, say D, F, G, are having intermediate nodes in between. So initially distance vector of node B are marked infinity. So likewise, all other nodes having its initial distance vector table entry. After calculating the distance vector to individual nodes, the next step is all nodes are going to share their network knowledge to its neighbors. That is, a node is going to share its distance vector table to its neighbor nodes. Here, node A has shared its distance vector to node B. The distance between node B and node A is 2. So for calculation of minimum distance from node B through node A is adding the value 2. Other neighbor to node A in given network is node D. So the total minimum distance of all other nodes from node B via node A is calculated based on Bellman-Ford equation. The distance between node B to node D is not direct. There is an intermediate node, so old distance vector of node B is filled with the value infinity. By using Bellman-Ford equation, the minimum distance found as comparing the old entry, that is infinity, and added distance with neighbor. That is, here the distance from node B to node A is 2 and distance from node A to node D is 3. So the added value is 5. So minimum of both the values, that is infinity and 5, is resulting 5. Then 5 is updated to new distance vector table of node B. Packet from node B can also travel through node E to reach the destination node D. But the total distance through node E is 9, that is higher than when a node B traveling through the intermediate node A and reaching the destination D. While performing by programming, all paths are going to be analyzed, but here, because of the manual explanation, directly node A is considered. Let's take another event when a packet travels from node B through the neighbor node E to other nodes. Node E is going to share its knowledge about the network to the node B, that is sharing its distance vector table to node B. Here the distance from node B to node E is 4, so the value 4 is going to be added whenever we want to calculate a distance from node B through node E to other nodes, that is next to node E. Here in this event, the distance calculation from B to F, that is calculation of minimum distance from node B to node F through node E is the addition of the distance B to E is 4 and the distance E to F is 2. So the total value is 6. So based on the equation, while comparing the old vector table, the entry in node B to F is infinity. So the minimum value of infinity and 6 is resulting 6. And the value 6 is updated to the new distance vector table of node B. So distance vector routing method is implemented in intra-domain, that is inside an organization network, and shortest path between source to destination is calculated as: the first step is to find the individual distance vector table of all routers to their neighbor routers, and the next step is routers are sharing their network knowledge to their neighbor routers. This method is eventually stabilizing the system and permitting the system to find the minimum cost. And after every updation, again the router will share their vector entries to their neighbors for further updation and finding the shortest path. Thank you.
How the next distance vector routing is happen in actual network. We will show one demo which will represent the your network packets and how the packets are travel in between two routers. Okay, let's see. Okay, if you are able to see here, this is the Cisco packet tracer software. Okay, here you can see PC0, PC1 and PC2. Okay. These are the 3 PC available here. Then 3 switches for 3 network, 1, 2, 3. Then I also have, you see, then I also have one network packet. Likewise, I also have 3 routers, router 0, 1, 2. Okay. So router 0, 1, 2, these are the router which are available for the different network. So basically we have 3 different networks. Okay. If you can able to see, now in this Cisco packet tracer we will create our network. I have made connection like this. We have to configure it according to our distance vector routing. We set the IP address, we will set different subnets for each network. Okay. Now we will configure also the routers. The router default first network is default IP address and the gateway is the 10.1. The last digit is 1. That is the routing IP address of that router. Okay. So likewise again for the network 2 and same for the third network. Okay. So this is the background part which is configured. Okay. This is the real-time simulator. Okay. In real situation also you have to configure like this. Okay. Suppose consider this is our college building, this is another building, and this is building situated in the Jalna or Aurangabad. Okay. So I want to send the packet from this destination to this. Okay. Configuration, all the things. Okay. The packet is travel, the desired path for the packet traveling using the distance vector routing is from IP address 192.168.10.2. This is the source and the destination is travel from one network to second to third, and here the destination will be 192.168.30.2. Okay. So you must know the difference between this network. If you see able to see the IP address, the first network has the 10.2 subnet and second has the 20.2 and third has 30.2. Means all are in the different network, different switches and different routers. Okay. Suppose it is not routed and it is broadcasted in the network, then what happen? The packet will go to each and every node unnecessarily. Okay. So here also will go and here also will go if it is not routed with the help of distance vector routing and using with the help of router. Okay. So we are applying here the distance vector routing algorithm to route our packet with the shortest path. So which is the shortest path? So it will be traveled through our network, the switch, then router. From here it will get the next hop. This here it will check whether destination is available with this network or not, and then after if it is given a routed path to this network, then it will go to this router, and again it will check for the IP addresses in this network, and if it is found, then it will go to this computer. Okay, so this should be the desired path. We will see whether it will happen or not. We will put the packets as a message in each router. So ICMP packet format we are using here. I have added the packet, empty packets, and source and destination. Okay. So let's see now, simulate the start here. Packet is here. Now it is traveling to switch. Okay. Data is loaded here. Then again it go to router. Router will check the route here. Okay. The route 1, it's sent to the route 1, router 1. Then again look here. When packet receive here router 1, if it is not applied a distance vector algorithm to check the shortest path, then this packet may be traveled to this destination for checking the destination. Okay, but as we know that we have applied the distance vector routing and just to check the shortest path, so this router will send the correct network or correct desired shortest path which is available here. Okay, so the packet is moving from here to here. Okay, now it is coming to this switch in this network. The PC is available and it is received at the destination. Now reply is coming that the packet is reached at the destination. The acknowledgement is again going to our source. The packet is received at the destination. This is the acknowledgement packet which is going with the same path. Okay. Yes. Again here. Now it is coming back acknowledgement that packet is received at the destination. Okay. So just now we have seen how packets are traveled in the network with the help of this vector routing and the routers. This is the application. I have shown you the application. Okay, application is necessary because theoretically, right, theoretically you won't able to understand exactly why this algorithm or routing technique is implemented. Okay, theoretically what you have, this is the routing algorithm you have to apply, and we have this diagram. The packet should go to this destination and these hops are present. Okay, but after that, if you see the simulator, then you are able to understand exactly what is happen in the network. Okay, that's why I have shown you that simulator, that you can note down that simulator name, the Cisco Packet Tracer. Okay, you can download it from the cisco.com website, and you can configure it, you can use it to check how this algorithm, how this routing is happen. Okay. So that's okay for now. I will end up with this my lecture. Thank you for watching today's lecture. In next lecture, we will cover our next routing technique. We will cover some other shortest path technique, just like link state routing, okay, and RIP. We will check these different kinds of routing in our next lecture. Till then, thank you. Please mark your attendance. Here is the attendance link. Okay, just mark your attendance.